So during this thing, we get the output voltage and current in this way. Now, if I put the duty ratio for different cases, that is for buck boost converter, put the duty ratio is equal to 0, then what will happen? The output voltage will be 0. If I put 0, T equal to. And if I put 0, then the current will be is equal to infinite. So it will draw infinite amount of current, which is actually not required for any system because it may damage the system. So d duty ratio 0 we cannot put. So we can use duty ratio equal to 0. 0.5. Then if we'll see the output voltage is one third, current will be 3. And if I put duty ratio equal to 0.75, then duty ratio voltage will be voltage will be 3 and the current will be one third. And if I put current is duty ratio infinite, duty ratio equal to 1, then we will get the output voltage infinite, which is also not required. So this case, when duty ratio equal to 1, then output voltage infinite and the current 0. This is actually the characteristics of boost converter. And when current voltage equal to 0 and the current infinite, it will be buck converter. So it is the combination of buck and boost converter. So for a transformer tapping, it is similar like this. So we cannot put 0 or 1 for duty ratio for using the same way. This is the drawing of inductive current waveform. The similar thing when switch is on, that is in between dt and 0, what we can see that the voltage, it is the inductive voltage, it is charging, and during that time it is the similar as the dc voltage. The inductive voltage is similar to dc voltage. So if I get the inductive current, we will get the slope, because if I integrate this, we will get IL equal to VDC by L dt. So VDC by L here in this case is the slope of the current for this waveform, you can see. And the minimum current you have to maintain to continuity, for the continuity of the signal. Okay, now when the switch is off, you can see it is dt, in between dt and t. So in these cases, the uh, inductive voltage is minus of output voltage, and it will be IL equal to minus V naught by L t minus dt. T minus dt is actually the of time of period, and during that time the slope is minus v naught by L, and that is shown here. Minus v naught by L is the slope for the discharging of discharged or discharging L inductive current. Okay, and this is the maximum current. You have to continue from maximum current. IL max is the maximum current. These are the proportionality constant, as well as it is to maintain the continuity of the signal. Okay, so when the switch is on means voltage is 0. Switch on means switch closed. That means voltage is no voltage is there, short circuit is there. So current is not equal to 0 there. So when switch is off, that means it is open, voltage is huge, and current is 0. That is short circuit. Sorry, this is open circuit, this is short circuit. So it is a first quadrant switch. So MOSFET can be MOSFET, or IGBT is suitable. And so this is the, here the capacitor waveform is similar as boost. Here in this case you can see this is the diode current waveform, because during the off time diode is switch on or forward biased. And so forward biased means the voltage is 0, and during the back when it is off, when the diode is off, then we'll get the output voltage, that is the diode voltage can be obtained. So this is the diode voltage waveform, this is the diode current waveform, and this one is the switch waveform. Switch current when it is on time means current is there, and this will follow simply the inductive current, since the inductance is there in between. So switch, whatever it may be, it may be switch, it may be resistance, whatever it may be, the charging, slow charging will only be reflected to every component. Okay, even if there is a resistance there also, you will get the slow increment of the current waveform or voltage waveform. Okay, so this is the voltage, switch voltage signal, this is vdc minus v naught. Okay, and so the peak to peak ripple current IL will be VDC by L into T plus IL minimum. At dt, it will be IL max minus IL minimum equal to VDC by L dt. So delta IL max minus IL minimum is delta IL, VDC by L dt. Similar as boost. Now if D equal to 1, IL max equal to delta L max equal to VDC T by L. These are very important equations. Always remember. So delta V naught equal to I naught dt by C. V naught max, delta V naught max equal to I naught C by C when D equal to 1. This is also similar to boost. Boundary conditions, LCR equal to VDC by I naught. Okay. This is for continuous and discontinuous conduction, similar like boost converter and buck converter. And these are the comparison of buck boost converter. As I have already told you, buck and boost has the output voltage dVdc, and boost, for boost it will be b naught vdc by 1 minus d, and buck boost combination is simply the combination of those two. Similarly, in the case of load current equal to output current, sorry, inductive current equal to output current, here also inductive current equal to output current by 1 minus d boost converter. These are the relations. Okay, so today let us end the session.